So it's 2:03 here on the East Coast, so we'll go ahead and get started. So thanks everyone for tuning in for this installment of the National Fellow online lecture series from AMSSM. So before we get started with today's lecture, just wanted to plug the next lecture in the series, which is going to be on May 6th at 2 p.m. Eastern Time. That'll be on the pediatric spine with Dr. Steve Simons. Today's talk, we have the pleasure of having Dr. Gary Green, who's a medical director for Major League Baseball and also a content expert on performance-enhancing drugs, and he'll speak with us today on this topic. Before we get started with Dr. Green's talk, just a couple of housekeeping notes. This, as we always mention, is not to take the place of any of the educational content that fellows get from their own programs. It's to serve as an adjunct and to assist with CAQ exam preparation. So everyone's devices will be muted today. Video will be off. If you have any questions along the course of the talk, please put that into the chat function at the bottom, and then I will ask the questions to Dr. Green at the end of his talk today. And then after the program, please complete the eval, which will be sent in the chat function as well. So with that said, I'm going to let Dr. Green take it away. Again, he's medical director of Major League Baseball and content expert on performance-enhancing drugs. So Dr. Green.
Great. Well, thank you very much. I really appreciate the offer. I think I did this last year as well and really enjoyed it. Can you see my slides there, Bob?
Yep, I can see it.
Great. So also before we start, just want to give you an interesting case. I was riding my bicycle. This is something I haven't seen before, so I thought maybe you guys would appreciate this. So I was riding my bike a few months ago, and my thumb got stuck into the handlebar, and I looked down and my thumb was like this. So I'm sure you've all seen mallet fingers before. And the thing that I had never seen before is a mallet finger on the thumb. And so I've been in a splint for 2 months now, and hopefully getting that off today. But even the hand surgeon I went to, who's quite experienced in this, he's only seen like 1 or 2 of these. So I just wanted to kind of do this. There was a little avulsion fracture on the extensor tendon, and it's usually about 8 weeks in there. And just to give you an idea of an additional treatment for this, that the hand surgeon has used in people who are like surgeons or dentists who have this, they can put a pin down through the bone, and so you don't have to wear a splint for 8 weeks. The problem is it has to be buried and then it has to be surgically removed. So I opted just for conservative treatment, and it's done well. So just as a little thing, again, I'd never seen that before, so I wanted to share that. So talking about performance enhancing drugs, this is a topic that we could spend. We do conferences that we go on for days about this. So I just want to give you kind of a brief overview, because obviously we can't talk about every performance enhancing drug that athletes use, but kind of give you a way of kind of looking at this. So before we decide where we're going, we have to know where we came from. And this is kind of the key slide in all you have to know about drug testing, is that every time you build a better mousetrap, the mice get a little smarter. And that's pretty much where we're at in drug testing, that we're always 1 step behind the athletes, but we don't want to be 2 steps behind. So I'll give you kind of the cat and mouse game that's gone on in drug testing for many years. So, the Olympics are coming up this summer, and we see this in a lot of teams, and you can see this from the Russian team. Our entire team has been banned for doping, even us girls. And this is important, not just because it's hopefully a little bit humorous, but also because the side effects of many drugs depend on whether you're a man or woman or a developing adolescent. And you may have seen, this would help certainly augment this talk, is there was a movie called Icarus, which was a documentary that won the Academy Award a few years ago. And it really traces the Russian anti-doping scandal. And for those of you who aren't familiar with this, this was in Sochi, that there was a state-sponsored anti-doping protocol that was done. And what they did was they had a little mouse hole in the secured area, and it looked like this, that they could remove. And then what they would do is they would pass the athlete's urine into this to the other holding room, and then they had the same athlete had given clean samples before, and they would pass it back and forth between them. And these were the bottles that were used at the time. that were supposed to be impregnable, but it turns out that they were able to be opened surreptitiously without any evidence. And the way they actually found this is that they did electron microscopy on the bottles and found little tiny scratches in there that indicated they had been open. And this is probably I think is the most important slide that came out of the investigation from the McLaren report. This is the number of, quote, disappearing positives. So athletes who are positive who they made disappear. And I think the interesting thing on this is if you look to the left, you can see that athletics and weightlifting led the league in the numbers of positive tests. But look down towards the end. Even they did this in curling, sailing, table tennis, judo, handball. So all sorts of what we would call minor sports that we wouldn't think would be subject to doping were part of this project. So I think the important thing to know is that doping is not just confined to elite athletes, it's not just confined to the high profile sports, but it's really anything. And when I was chaired the NCAA drug testing committee, we had positive tests in Division I football, scholarship, top 20 programs. And we also had a positive in a Division III walk-on girls cross-country athlete. So it really ran the gamut. And this is not a new phenomena. The ancient Greeks and Egyptians and Romans all gave their athletes magic potions to make them run faster, jump higher. And 1896 was the first documented athlete use of death. The 1950s, anabolic steroids. And, we have this, we think now that there are all these scandals. Well, imagine you were watching the Olympics in 1960 and a Danish cyclist died of an amphetamine overdose right during the middle of the Olympics. And the desire for athletes to work harder and try to win an Olympic victory goes back to 2,000 years ago. And this is from the Getty Museum out here in Southern California. And on the left is the athletic trainer of 2,000 years ago. And we know this is the athletic trainer because he had the equipment they used was a pointed stick that they used to prod the athletes to better performance. And this is Arthur Linton. He was the Welsh Grand National bicycling champion in 1896, and he died of an overdose of strychnine and trimethyl that was given to him by his trainer. And this is Tom Simpson, who was a Tour de France rider, and he famously said, if it takes 10 pills to kill you, I'll take 9. Well, he'd have been better off with 8 because he died of an amphetamine overdose in the middle of the Tour de France in 1967. And this is a picture of his unsuccessful resuscitation at that one. So this is not a new phenomena by any stretch of the imagination. And it's also important to remember that athletes don't exist in a vacuum. As the positive drug test might be the tip of the iceberg, but below that, we have their advising physicians, scientists, researchers, social network, their peer group, and coaches and athletic trainers that are all contributing to a positive test. But the athlete is what gets reported in the papers. So I guess before we get into this, why do we even care about this? Well, why not just let athletes do whatever they want and who cares? Well, there's health and safety issues, as we'll talk about. We just saw that, people can die of these things. There's the integrity of the sport. Some of these drugs are work so well that they can really change the nature of a sport. And then there's the ethics of fair play. And then what if we don't do anything? What happens in that case? So since we can't address all the drugs that are being used by athletes, we've kind of come up with what we call sports pharmacology, which gives us a kind of a taxonomy of how we classify these, as opposed to medical school where we list things in pharmacology by their action or by their chemical class. In sports pharmacology, we list it according to the action of the drug. So for example, we have 3 categories. The first is ergogenic, which is to improve performance. So that would be potentially a weightlifter taking anabolic steroids. The second is recreational, and this would be recreational is to get high, to relax. And athletes, as we found, are at no greater risk or protection because they're an athlete. And certainly we've seen many cases of athletes succumbing to recreational drugs. And then the last one is therapeutic, which would be to treat an underlying condition. So an example would be insulin-dependent diabetic using insulin so they can compete. And why is this important? Well, you can use the same drug can be used 3 different ways. So let's take the drug like amphetamines. So it can be used ergogenically by athletes to improve concentration and energy, as we've seen with cyclists. It can be used recreationally in the form of methamphetamine. And then, of course, it can be used therapeutically for the treatment of ADHD using amphetamine, dextroamphetamine, and salts. So the same drug, but used 3 different ways. And I think we can certainly understand that the treatment or how we would assess an athlete using amphetamines would be very different depending on the circumstances. So how does a drug get put on the banned list? Well, the World Anti-Doping Agency has 3 criteria for inclusion, and it must fulfill 2 of the 3. So number 1, it has the evidence for or the potential for to enhance performance. And again, it doesn't have to have strict evidence that it does. Evidence that the use poses an actual or potential health risk. And then the third is kind of this little bit of a vague one, that it violates the spirit of sport. So that's how a drug like marijuana can be on the ban list, because obviously it doesn't enhance performance unless it's maybe, eating Doritos or things like that. It can certainly pose a potential health risk, but it violates the quote spirit of sport. And what the World Anti-Doping Agency, their prohibited list puts things into various categories: anabolic agents, peptide hormones, beta agonists, hormones, diuretics, cannabinoids, glucocorticoids. And we'll talk about a few of these in a little bit more detail. But one of the key things for any doping control program is this sentence at the bottom. It says, and other substances with similar chemical or biological effects. And the reason for that is, as we'll see with anabolic agents, is you can't ban every single drug that somebody might come up with. And this way it effectively bans designer drugs that may not be on the ban list, but are similar chemically or biologically. They also ban substances in particular sports. So for example, beta blockers would not be very helpful in, for example, running or playing most sports, because they would actually have a performance decrement effect. But there's certain sports where beta blockers actually have an ergogenic effect, and they would be in the shooting sports. In these sports, and also in golf, in terms of calming down tremors and things. But the reason in shooting sports is it turns out that your heartbeat actually can throw off your aim slightly. So elite shooters they do biofeedback, and they try and shoot in between the heartbeats. So you can imagine if your heartbeat's 40, it's a whole lot easier to shoot in between the heartbeats than if your heart rate is 80 or 90. So beta blockers are banned in those particular sports, also in auto racing as well. And then the other thing is manipulating blood or blood components, because let's say you take your own blood out, store it, and then reinfuse it. It's obviously not a banned substance because it's your own blood, but it's the manipulation of blood components. And this was an Austrian skier who was tipped off. The police were tipped off that was going on there, and he was caught with a needle and a transfusion in his arm, and he was disciplined, and I think he was banned from the sport. And it's pretty hard in that situation to claim that it wasn't, I don't know how it got there. It was just sitting there in my arm, and I just walked by. So he actually gave a talk to one of our drug anti-doping conferences, and was very contrite about what led him to enter into this thing. In Major League Baseball, we group things by drugs of abuse, performance-enhancing substances, stimulants, DHEA, diuretics, and then any new scheduled 1, 2, or 3 substances automatically added to the list. The NCAA does it a little bit differently. They list things by stimulants, anabolic agents, diuretics, street drugs, peptides, antiestrogens, and beta-2 agonists. Now, one of the key things for any doping program is the use of a therapeutic use exemption, because as we talked about, some drugs can have therapeutic uses, and we have to be able to allow an athlete to use a drug for legitimate purpose. And these are basically the criteria: that it's needed to treat an acute or chronic medical condition, that they would experience a significant impairment if the drug were to be withheld, it's unlikely to produce any additional enhancement, there's no reasonable therapeutic alternative, and it can't be the consequence of a banned substance. So for example, if you take high doses of anabolic steroids for many years and you shut off your pituitary gonadal axis and you need testosterone replacement, that would not qualify for a therapeutic use exemption. So why do athletes use performance-enhancing drugs? Well, obviously to enhance performance. And this gives you a really good example. This was the Athens a rowing race in 2004. And you can see that Great Britain won by 0.08 of a second, or 0.02% of race time. So if you had to do a randomized controlled study to see if there was a performance effect between these two boats are statistically significant. And if you did a power analysis on this, you would need about 1 billion subjects in order to prove a difference. But obviously, a gold medal is very different than a silver medal, even though the difference statistically between these two boats is exactly the same. So athletes, will use things that have very small effects just to get that extra little edge. So kind of one of the examples of ergogenic drugs we'll talk about is anabolic steroids. And these are anabolic androgenic steroids. And they have both anabolic, which means building up of the body substance, and androgenic effects, which are male secondary sex characteristics. And it's the anabolic reason that they take these, and the androgenic effects that are responsible for their adverse effects. So first of all, do they work? Do they actually increase muscle? Well, if I was giving this talk in the 1960s, I would have said, nope, these studies were studies, we've done studies, there's no increase in strength, and multiple studies showed that. Well, the studies in the 1960s suffered from two major flaws. One is they used untrained individuals, and second is they used replacement doses of anabolic steroids. So if you take two groups of people who have never lifted weights or are untrained, and you put them on a weight training program and you give them steroids, both groups are going to increase their strength, regardless of whether they had anabolic steroids or not. So the anabolic steroid effect would be lost. Second of all, if you just give replacement doses, all you're going to do is shut off your body's natural production of testosterone and replace it with what you're giving from the bottle, and you're not going to have much of a net effect. So that wasn't how athletes were taking these things. They weren't taking replacement doses. Here's an example of one bodybuilder taking 4 different anabolic steroids, and you can see that the dose that he was taking was many times higher than the therapeutic dose. So it actually wasn't until 1996 that Dr. Shelley Basheen did the definitive study where he took experienced weightlifters and gave them 3 times the physiologic dose of testosterone. And what he found was when you do that, you get hypertrophy of the muscle when combined with a weightlifting program and a high protein diet, as well as super physiologic doses. Well, I don't think athletes were waiting for Dr. Basheen to do his study. They were doing this well. They were doing their own studies well before this. And I'll give you an example of some athlete, quote, studies that they were doing. This is the women's shot put final, Olympic Games, 1972. And in red, you see Helena Fabingarova from Czechoslovakia. She finished 7th in 72. 3 years later, she improved her throw over 2 meters and finished 3rd. So here she is in 1972. And here she is in 1976, 4 years later. Quite a dramatic turn. And we now know that in 1972, the Eastern European countries began an androgenization program of their female athletes to give them high doses of anabolic steroids. And here's another example of a study that they did. 1972, East Germany, women's swimming, no gold, 2 silvers, 1 bronze, no Olympic or world records. 4 years later in Montreal, they won 10 of 11 individual golds, 5 silvers, and they set 10 Olympic or world records. And again, from the declassified Stasi records, we know that 1972, they began giving their women athletes high doses of anabolic steroids. 20 years later, in 1992, the 2 Germanys were now united. The wall had come down. And look at their results, almost identical to what they were in 1972. Now that they stopped their little experiments, you can see that they're back to about where they were 20 years earlier. And here are some examples of the anabolic steroids that athletes typically use. The last 2 in red I put down there because although they're commonly used by athletes, these are veterinary products not approved for human use. So trenbolone is used in cows and boldenone is used in horses, but they're prized by athletes for their anabolic properties. So The other thing is, you know, in addition to athletes, this has now gone way beyond athletes. If you Google buy testosterone, you get 25 million hits, and we have lots of anti-aging clinics willing to sell people testosterone. But there's lots of adverse effects on this. On the cardiovascular, we see lowered HDL cholesterols. I've seen, believe it or not, with weightlifters, I've seen HDLs in the single digits, like 7 or 8. Gastrointestinal problems with liver cancer. Obviously, the GU is affected, and several others, which we'll talk about in a minute. Let me go back here. Sorry. We have musculoskeletal. You'll have tendon ruptures because although the muscle hypertrophies, the tendon does not strengthen symmetrically. So you can get, and not just regular tendon ruptures like, you know, Achilles, but you'll see pec majors, psoas muscles, ones that are a little, triceps, ones that are a little bit more unusual. And one of the most damaging things we see is in youth. We have premature closure of the epiphyseal plates, accelerated puberty, and significant depression and suicidality. And these are examples of 3 young athletes who killed themselves following use of anabolic steroids. You may have heard of Taylor Hooton. His dad created the Taylor Hooton Foundation that MLB partners with, and they are committed to steroid education, anabolic steroid education for youth to helpfully avoid the fate that befell their son. And this is a suicide note from a steroid user who said, "Stop using steroids, they'll destroy your life or anyone with you." So while these things are not, you know, fortunately common, they do occur. So how do we detect these things? How do we test these things? Well, gas chromatography mass spec is excellent for synthetic anabolic steroids. And as I talked about at the beginning, when you make a better mousetrap, the mice get smarter. So athletes turn to natural testosterone, which everybody makes. And detecting testosterone use was very difficult. So what we came up with was the testosterone epitestosterone ratio. And what happens is, for every molecule of testosterone that your body produces, it produces 1 molecule of epitestosterone, which is a biologically inactive substance, but fortunately is very useful for drug testing. So what it does is most people have about a 1-to-1 ratio. Well, if you give somebody testosterone, your T will go up and you suppress your epitestosterone, thus the ratio increases. So normal is about 1-to-4 with a small number of people in the 4-to-10 range. And most organizations now have a cutoff of about 4-to-1. So if your ratio, let's say your ratio has always been 1-to-1, and we're monitoring somebody, all of a sudden it goes to 5-to-1, then that's proof of you're using exogenous testosterone. However, again, the mice got smarter. So athletes have been known to manipulate their TE ratio. So they can take oral or skin preparations of epitestosterone. So by doing this, they actually are able to maintain their TE ratio in a normal ratio. There's also some evidence that the TE ratio can change slightly with exercise, with sex, with alcohol. And there's also genetic differences with how T and E are metabolized. So for example, people who are Asian tend to have very low TE ratios, usually under 1. And it turns out that if you take somebody who has a very low TE ratio, they can take a whole lot of testosterone without raising their ratio. So this caused problems in terms of how we did this. So we had to come up with something else. And what we came up with was the carbon isotope ratio. So I have to apologize for some chemistry and science on this. And this is something that starts out relatively simple, and then the pool gets really deep really quickly. So here's the simple part. Most carbon in our body is carbon-12, which is 6 protons and 6 neutrons. And that's about 99% of our body is carbon-12, and about 1% is carbon-13. Well, it turns out, is about 1.1% carbon-13. Well, it turns out that synthetic testosterone is about 1% carbon-13 and 99% carbon-12, and it has that extra proton in carbon-13. So it's got 7 neutrons and 6 protons. And so what happens is that small difference is actually statistically significant. So here's a very complicated formula that we use. So what we do is we take the ratio of carbon-13 to carbon-12 in the sample, subtract it from what's called PDB, which is a standard that's relatively high in carbon-13, and then we subtract it by the ratio of carbon-13 over carbon-12 for this PDB standard. So here's just a quick example. Let's say the sample is 1.08% carbon-13 and 98.92% carbon-12. So if you do this calculations, you get a ratio of minus 28.39. Well, look what happens if you just change it 0.02%. Well, you go from minus 28 to minus 10, which is very significant difference. So here's what happens is, let's say somebody takes testosterone, okay, or androstenedione. And this is kind of like, what we do is, it's kind of like if you put some red dye in the middle of a river, and then you take a sample of the water both above and below where you put the red dye in. So if you look at pregnenolone on the top, so that's a precursor of testosterone. So let's say the delta level of that is minus 26, and then the testosterone is minus 26, and then the metabolites of testosterone are minus 26 and minus 26. So if someone's not using any synthetic testosterone, it'll be pretty much the same ratio all throughout, both above and below. But look what happens if you take androstenedione that has, let's say, a minus 31. Well, the precursor still stays at minus 26, but the testosterone and all the metabolites go down to minus 31. So that we compare, so actually each person can serve as their own control, because we compare the metabolites to the precursors and they should be the same. So this can detect very small differences in carbon-13 versus carbon-12. And because exogenous testosterone has less carbon-13 than natural, this is something that we can measure. And I actually did, so this is because soybeans are very low in carbon-13 compared to other plants, and exogenous testosterone is made from soybeans, soy plants. So your question, I'm sure, would be, well, why can't somebody just eat soybeans? And they claim that that was the reason for their positive test. Well, I actually went to a commune a few years ago in Tennessee, and this is a commune that has a soy diet. They're totally vegetarians, and they mainly get most of their protein from soy. And I took urine samples from them, and it turns out that their numbers are slightly different than a group of controls, but it has to do with all throughout their precursors as well as their metabolites. So diet does not influence it. So the only problem with this is now people will try to produce testosterone that has extra carbon-13, and they can do this very cheaply. So it's cheap to mask testosterone. It's expensive to detect because IRMS is detecting. And we did a study where 60% of the seized testosterone in Austria had masked IRMS values. So again, every time we build a better mousetrap, the mice get a little smarter. So what did people do? Well, they're turning to what we call Sarms, selective androgen receptor modulators. And these are androgen agonists or antagonists. None have been approved for human use, and they have the potential to be anabolic without causing the androgenic effects. They've been banned in both with World Anti-Doping and in Major League Baseball for over a decade, but this has not stopped athletes from still trying these. Our first positive, and the first one reported worldwide, was in minor league baseball. This player tested positive. He was a single A player, which is the lowest rung of the minors. He had researched it. He didn't think it was detectable. He was, obviously the internet is not always correct. He got a 50-game suspension, and it was the first reported case worldwide. So what do athletes do? Well, again, they're turning to other things like human growth hormone. Why do athletes use growth hormone? Well, it can technically be lipolytic and decreasing fat. And it was for a long time undetectable because it was identical to exogenous growth hormone. And the use of growth hormone, whether natural or with pituitary extract, dates back to at least 1988. In the Tour de France in '98, they found lots of recombinant growth hormone there. The entire Chinese swim team was sent home from Sydney because they found growth hormone in their luggage. And we've had cases of trafficking in this. So is it ergogenic? Well, theoretically, yes, but there's been no controlled studies. So one of the reasons why maybe we're not seeing this is maybe we're back like where we were in the 1960s with anabolic steroids, that we're not testing at high enough doses. And obviously right now it would be very difficult to ethically give people high doses of growth hormone that have significant side effects. I don't think you could get that through an IRB right now. So how do we detect this? Well, growth hormone is not one substance. It actually comes in isoforms of different sizes from the 5 to the 22 kilodalton sizes. And what happens is the recombinant growth hormone is only the 22 kilodalton isoform, whereas from the body you have multiple different isoforms. So what happens is, if you take, we look at the ratio of the 22 to all the other isoforms, and we come up with a threshold. And what happens is, if, just like with testosterone, epitestosterone ratio, if you take recombinant growth hormone, you're going to increase the recombinant 22, and you're going to suppress the other ones. And you come up with a threshold of 1.45 in men and 1.8 in women. And the first positive test for this was the English rugby player who the club knew that he was receiving packages of growth hormone. So they targeted him for testing. He tested positive, and he admitted to testing, and it validated this isomer test. Unfortunately, he committed suicide later that year. I'm not sure if he was taking something else or if just the fact that it ruined his career, but that was an unfortunate complication there. And in July 2011, we had a positive minor league baseball player who tested positive with a truly random test, and he later admitted to using growth hormone. And we began doing minor league testing in 2010 and the majors in 2012. The interesting thing is, although we've been doing thousands and thousands of tests per year, and this is a blood sample, not a urine sample, we have not found another positive since that time. So what's the reason for this? Well, I think there's a couple of reasons why we haven't found a positive test. And the Olympics began using this in 2004. They've had about 8 positive tests, and they haven't really had very many others since that time. And one of the reasons is it only detects use for about 24 to 48 hours. So you have to really be lucky if you're going to catch somebody using human growth hormone. So again, we had to come up with something else, a different test. And what we came up with was an indirect test called the Pharmacodynamic Test. And what this means is, instead of measuring growth hormone, we're measuring the effects of this. So it turns out when you take human growth hormone, you increase IGF-1 from the liver and procollagen type 3 or P3NP from bone. And it measures the actual effect, and it can detect up to 2 weeks of use. And it was used in the London Olympics in 2012, and it's been widespread since 2016. So basically what happens is, to the left of that diagonal line is people who are not using, and to the right are people who are using. And what you do is you come up with an algorithm of the levels of IGF-1 and P3NP in order to detect it. And it had to be validated for multiple conditions such as ethnicity, injury. You know, is it possible that if you had a fracture, it would cause your P3NP to go up? And what we found was that none of these things interfered with the test, and that after 14 days, you can get up to 20% people still being positive. And the first positive was in 2012 at the London Olympics, where 2 Russian, no surprise, but Paralympian weightlifters tested positive. They did a second sample 2 days later, also positive. Both athletes admitted to use, and it showed that it was valid. But we really haven't seen any other positives since that time. Again, questioning, are athletes staying below the level, or did they stop using growth hormone? And it's important to remember in the US that even though we have lots of anti-aging clinics, HGH, recombinant HGH, is the only drug that I know of that cannot be legally distributed for unapproved use. So it's the only drug that can't be used for off-label indications. And these are the only indications that you can use for human growth hormone. So if somebody is using it for anti-aging or injury recovery, it's an unapproved use. And technically, even if a physician writes it, it's technically not a valid prescription. So it has to be, again, a valid prescription from a physician, a recognized medical condition for an FDA approved use. So again, what are the mice doing now? Well, they're trying other things such as growth hormone releasing peptides, ipamorelin, and maybe this will defeat detection by the isomer test. However, these things are all detectable through gas chromatography mass spec. And these things, again, are not approved for human use. And this is an Australian rugby player who had Hodgkin's lymphoma in remission. He began using these growth hormone releasing peptides, and it reactivated his Hodgkin's disease, and he unfortunately passed away. So we've talked a lot about strength, how we increase strength, but what about improving aerobic performance? So if you want to improve oxygen delivery in aerobic performance, you can increase cardiac output, you can increase red blood cell mass, oxygen transport substitutes, improved oxygen unloading, and genetic engineering. And in the 1960s, blood doping was common. 1986, recombinant EPO was developed, which really pretty much eliminated blood doping for a while. Extended release EPO called darbepoetin came out in 2002. New EPOs came out, SERA, which I'll talk about in a minute. Hypoxia-inducing growth factors like HIF and VEGF are all things that potentially can improve oxygen delivery. So we pretty much didn't have a way of detecting recombinant growth hormone because it's very similar to naturally occurring EPO. So what we did was we came up with isoelectric focusing, which basically recombinant EPO has sugar moieties that have charges that are different from natural EPO. And what happens is these things migrate. If you put them on a pH gradient isoelectric field, they migrate at different ways. So you can see over here that this is the negative control, this is the EPO standard, and this is a positive. So if you drew a line here, if it falls below here, it's a positive for EPO. Well, then athletes turn to darbepoetin, which is NESP, which is a long-acting one, and because it migrates at a different field. Unfortunately for the athletes, this is very detectable up over here.
As it stands now, it's just a wild card.
So again, this is very easily to detect in urine. So again, what did athletes turn to? Well, there's something called SERA, which is continuous erythropoiesis receptor activator. It's marketed in Europe, and because it's a pegylated compound, very little is excreted in the urine. So this is what it looks like. So on the right is the EPO molecule, and on the left you can see how this polyethylene glycol thing is significantly larger, and because of that, it's not excreted in the kidneys. So you don't have much in the urine, which allows it for patients to last for a lot longer time. So what we had to do for this one to detect this is do blood testing, and because it stays in the blood for quite some time. Lots can look at, for example, their hemoglobin and their, you can look at their hemoglobin and you can look at their retic counts, and you can come up with what's a normal range for them. So all of a sudden, if somebody falls up here, something happened. So it could be that they went to altitude, it could be that they took EPO, it could be they gave themselves a transfusion, and this would trigger further evaluation. The other thing that to deter people is storing samples. You know, we found that our testing methods increase or improve over time. So they store the samples for up to 8 years, and then they've later disqualified people after the fact. So just to finish up, we'll talk about, is drug testing the answer? Well, H.L. Mencken said there's always a well-known solution to every human problem, neat, plausible, and wrong. So again, as we talked about at the beginning, every time you build a better mousetrap, the mice get smarter. When we do drug testing for athletes, it's witness testing. So you basically have to disrobe in the strike zone, which is from like the chest to the knees, to ensure that this is an adequate sample. But athletes in other sports have tried to come up with other ways, like the Wizonator, which was very popular for a while. And you might ask, what is the Wizonator? Well, this is what the Wizonator is. It's an artificial bladder and penis that you can put some reconstituted urine in there to see if you're and to see get clean urine in there. And this is not all that it comes with, but in case it's being witnessed partially, it comes in different colors so that you can match your hands to the color there. But unfortunately, that wouldn't work in most professional sports drug testing because it's witnessed. So athletes had to come up with other things. So this was called the MACID machine, and this was used at the Athens Olympics by several athletes. And you see this orange line here. Well, everything to the right of the orange line was put in the athlete. So that red bulb was put in the rectum. It was filled with clean urine. And then the rest of it was taped underneath the perineum, and there was a little spring there to simulate urination. And unfortunately, this did not work as this was pulled out of two Bulgarian weightlifters who lost their gold medal from the use of this device. So it's important with drug testing what a drug test can tell you, but what it can't tell you. So a drug test cannot tell you the brand, the formulation, whether it was by mouth or injection, how much was taken or how long before it was taken. So for example, someone could have taken a small amount recently, or they could have taken a lot more remotely. And a urine test can be negative for several reasons. Obviously, if it was never used, it can be negative. If it was used a long time ago and had been eliminated, if it's below the limit of detection, if it's a designer drug that the lab can't find, or if it's not being tested for in that program. And it's important to realize that Ben Johnson passed 19 drug tests, Kelly White passed 17, Marion Jones reportedly passed 116 tests, and Lance Armstrong claimed he never failed a drug test. Different organizations have different penalties. In Major League Baseball, it's an 80-game suspension for the first positive, then 162, and then life. The NFL has a 4-game suspension, the NCAA 1 year, and the Olympics have a 2-year. And it won't deter everyone. There's 3 types of people. There's some people who will obey the rules no matter what. Some people who obey the rules to avoid getting caught. Those who will disregard the rules no matter what. And before we get too hard on athletes, ask yourself, which category are you in? When do you slow down? Do you slow down when you see it says speed limit 65? Do you slow down when it says radar enforced? Or do you slow down when you see the policeman with the radar gun? So everybody has a different category that they're in. And a successful deterrence program really has to have all of these qualities in it, with very high quality testing, an appeal process, and deterrence. So I'm going to skip ahead a little bit here just to give you a quick little example here. This is the Partnership for Clean Competition that was founded in 2008, and it's partnered by MLB, USADA, the NFL, and we have other partners as well as the NHL and the PGA. And we've pooled our resource, and we're actually now the #1 funding agency for funding anti-doping research. And we've done lots of different projects. If you're interested, if you go to cleancompetition.org, you can see what we do there. We've done projects looking at other types of matrices, such as oral fluid or exhaled breath as alternative matrices. Unfortunately, the COVID epidemic kind of put an end to this research in this area because of the potential for contamination. And then I guess I'll end with, can change happen in sports? Well, here's an example. The MLB obviously had a steroid program in the 90s and early 2000s. Senator Mitchell came up with a report that he issued that really changed baseball. Since that time, MLB has embarked on one of the most ambitious drug testing programs that we have. We test umpires, we test all non-playing personnel as well. And we do about 10 or 11,000 tests a year, including blood testing. And fortunately, we have very few positive. Our positive rate's about 0.07%. And we also test in the minor leagues. And you can see that this has gone down dramatically since we started our program as well. And just to show you how change can happen, I don't know if any of you have been to the Dominican Republic, but it's an island of about 10 million people. We have about 20% of our players come from the Dominican. And when you go to the Dominican, to the resorts, it looks beautiful, but it's also a tale of two islands where you have people living in really abject poverty. MLB has all 30 clubs have academies there that are like college dormitories now. They provide education, housing, and training. And baseball in the Dominican is about 20% in our minor leagues come from the Dominican, and the average salary of these players is over $4 million. Some of these players are the biggest stars in baseball, and there's a big risk reward. So one of the things they say in the Dominican is baseball is hope, because it can really provide not only for the player, but for their family and for their whole community. So in the Dominican, they don't have the infrastructure to develop youth talent. And Buscones are finders who sign these kids at 12 years old. And there's about 50 or 60 million in signing bonuses in the Dominican annually, and the Buscones take a percentage of that. So there's a big percentage to be bigger, faster, and stronger. And the other problem is anabolic steroids are not illegal in the Dominican. You can go to a pharmacia and buy it without a prescription. There's also an injection culture there. And again, these Buscones have a very high degree of trying to get these players bigger. However, we've been very successful despite huge challenges. And what we did was, up until 2008, we were only allowed to educate people. We weren't allowed to discipline people. So you can see the effect that that had. Once we added sanctions, we saw a further drop. And then we added financial disincentives. So for example, the Buscones don't get their bonus until the player passes their drug test. So with all of these things, we've been very effectively deterring the use there. So I'll just end with, if you look at these major scandals in sport over the last 50, 60 years, one of the things that they have in common is none of them would have been possible without a physician help. So before we get too hard on the athletes, we have to look ourselves in the eye as well. And this was a particularly good quote from Reika Reinisch, who was one of those East Germans who won a gold medal, said, "The coaches and doctors were our guardians, the people we trusted. I'll never know how good I could have been without sports." And I think that that's really important to know, as we talked in the beginning, that the athletes don't operate in a vacuum. They have a lot of people encouraging them to either use or not use drugs. And we started this about 45 minutes ago talking about how cheating has been going on in sports for thousands of years. Well, it's also important to know that competing fairly has also been an ideal for thousands of years. And this is the Greek dramatist Sophocles, who said, "Rather fail with honor than succeed by fraud." And I think it's important to know that even though it's the athletes who test positive who get the headlines, the majority of athletes do want to play by the rules and do abide by that. And so the reason we do drug testing, or one of the reasons I've done this for the last 30 years of my career, is to ensure that those athletes who want to compete fairly don't feel that they're at a disadvantage. So with that, I'll stop, and I think we have a few minutes for questions. So thank you.
Thanks so much, Dr. Green. I'm going to let everyone attending, there are no questions in the chat currently, but
Okay.
I'm going to give them a few minutes to put some questions in the chat. So I'll pull, I think my screen is, give me a second. And I'll share my screen again and put this up. So I have a question. So I use for athletes or patients coming clinic, I have the NSF app that I use to just look up products to be able to tell them yes or no, I think it's okay to take or not take. Do you have any other recommendations for apps for the phone or resources that as physicians, or even that we can give to patients that would be useful and as a quick resource?
Yeah, that's a great question. NSF for Sport is the one that we use with MLB, and we partnered with NSF to do that. And what we did with, one of the ways we dealt with the problem is that athletes, when they tested positive, claimed that they just took a supplement and it was contaminated. And we do know, I did research at the UCLA Olympic Lab in the past, and we found at one point 11 of the 12 supplements that we tested did not contain what was on the label and contained contaminants. And that's been replicated many times. So in order to do that, what sports organizations adopt for drug testing is what we call strict liability, which means if it's in your urine and if it's in your urine and it's a valid test, you have to own it. You're liable for that. So we eliminated the excuse of if you, I took a contaminated supplement. And in baseball, what we do now is the only supplements you're allowed to take are ones that are NSF certified for sport. And in fact, the clubs provide that now for their athletes. So you can use the NSF app. The other one is USADA has a Athlete 411 that also is very good resource as well, that can provide information for athletes. But I think, the message you have to give to athletes is if you're subject to drug testing, you should check these out before you take anything, because the likelihood of contamination is very high.
Okay, thanks. We do have a couple questions now.
Sure.
So Kim Fulton asks, could you mention the changing cutoff values of THC?
Yeah, that's a really contentious issue, and there's been some change. The NCAA had a very low level. I think it was 15, and I think there was even talk of lowering it to 5. There's big debate in the Olympic movement as to whether THC should be considered at all. Many organizations have taken it off their list. The NFL is considering, doing that. So I think it's a really, each sport has to make their decisions on this. So I think, right now the Olympics, I think, has added it to like 150 nanograms per mil, which is pretty high level. And so I think that's something that we're going to have to keep an eye on. And I think I think the argument that athletes will often say is, well, it's legal. And my response to them, well, there's lots of things that are legal, that are prescription, that are legal, that athletes can't take. So there are different criteria if you want to play sports that you have to adhere to. And I think most people would find that THC is not performance enhancing, and in fact, decreases performance. And I think that there's a lot of part of it is that the public wants to see athletes perform at their best and not doing things that way.
I have a few more here. Have a question and not necessarily related to sport, but if you have a comment on it, anti-aging clinics are starting to incorporate nandrolone into their testosterone replacement treatment protocols. And the question is do you feel this is safe or legal?
No, don't think it's safe or legal. That nandrolone has quite a bit of effects. Nandrolone is one of the ones that depresses HDL more than most of the other anabolic steroids. And again, you're just suppressing your natural testosterone. And one of the things that happens then is it's very hard to get off these things, because I've had patients who are taking high doses of anabolic steroids, and I believe are psychologically addicted to this, and it's very, very hard to get them off of their regimens. They get addicted. It almost becomes a reverse anorexia, where they get this, quote, Adonis syndrome, where how we have you've taken care of anorexics who they look in the mirror and they're 100 pounds and they think they look fat. Well, these guys look in the mirror and they're buffed up like the Michelin Man, and they think, oh, my triceps is a little smaller today, I think I better take something else. And they get this body dysmorphia image that goes on with that. So yeah, nandrolone is not a good one. It definitely increases your cardiovascular risks, and would not recommend that.
Okay, we have a couple more here. From Peter Rippey. Sorry, Peter, if I mispronounced your last name. But his question is, for my non-professional athletes, how much stock can I put in findings on regular blood tests like elevated LFTs or increased hemoglobin, et cetera? He's asking, am I basically at the mercy of the athlete to fess up, or are there some things on regular standard labs that you can look for as an indication?
That's a really good question. I thank you, Peter, for asking that. I think that just like you do with any other drug that you're seeing when you're a primary care physician, is I think you have to have a suspicion. And if you see somebody who's getting, for example, gynecomastia, someone who has gynecomastia, elevated LFTs, and their hemoglobin is 18, I think that you have to talk to the person and just like you would with somebody who's dealing with alcohol. So say to somebody, when I'm without judgment saying, I'm seeing these things here, I'm seeing X, Y, and Z, and these are often associated with, androgenic anabolic steroid use. And I need to ask you, are there things that you're using? Can you tell me what supplements you're using? Can you tell me, what this is? And I think you have to have that clinical suspicion, just like you would with, with anybody else that it's, having a substance use that may be affecting their health in an adverse way.
Great. And this is the last question that we have, again from Kim Fulton. And she asks, can you review the guidelines for caffeine, and are these things still in effect?
Yeah, caffeine's been taken, again, it depends on which organization you're subject to. The NCAA, I believe, still has caffeine on their ban list, but at a very high level. So just as an example, in order to trigger the level for caffeine, you'd have to drink about 8 cups of coffee, like probably 800 milligrams of caffeine in a very short period. The one thing though that, and again, in my time on the NCAA, we only saw one positive caffeine positive, and that was interesting, was somebody who only had about 2 cups of coffee, but they were on an SSRI. I think it was Lexapro, but I'm not 100% sure. But SSRIs can increase the levels of theophylline and methylxanthines like caffeine. So you have to be careful if somebody is using an SSRI, that it can increase their caffeine levels. But in general, the level is set so high that you really would have to almost intentionally get to that level. But most organizations have taken that off the list now.
Okay, thanks. And I was incorrect. We got another question that came in right after I asked the last one, and so I feel like this will be the final one.
That's okay.
And again, the question is in relating to testosterone replacement. And they ask, I'm seeing a lot of former athlete patients who want testosterone replacement in their 40s. What is your opinion on how to manage or counsel these patients?
Yeah, I think, first of all, I think you have to look at, there's a lot of things that go on. If you look at, there's a questionnaire that was developed by one of the drug companies to determine if you need testosterone replacement. And it's basically, are you tired? Do you feel sometimes low energy? And, most people in their 40s and 50s feel that at some point. And they're very vague questions. And in fact, it's a 6-question. I was testifying in a case where this was brought up, and it turns out that the guy wrote this in 10 minutes while he was sitting on the toilet. And that's how he came up with these 6 questions. And so people will look at that. So a couple things. First of all, if you do want to check their testosterone, it's very important to check it in the early morning. Testosterone has a diurnal variation where it's highest in the morning and then it goes down later in the afternoon. So a lot of these anti-aging clinics will have people come in at 3 in the afternoon and say, oh, your testosterone's low. And the other thing is you have to check both the free and the total testosterone, as well as sex hormone binding globulin, and if you need FSH, as well. And you should probably be doing at least 2 or 3 repeat tests early in the morning before you would say that somebody's low. And then the other thing is, I tell people that, first of all, if you take testosterone replacement, it doubles your risk of cardiovascular disease. So that's the first thing. And then the other thing is, if you take testosterone replacement, then you're really committing yourself to almost lifelong treatment. And that turns a lot of people off, because what you're going to do is you're going to suppress your testicular production of testosterone. And then when you go off it, you really are going to have low testosterone. And low testosterone, they'll read these anti-aging clinics that say your testosterone should be high normal, it shouldn't be low normal. There's no evidence of that at all. Now, again, if somebody is having symptoms such as low libido, erectile dysfunction, things like that, that's a different story, and that should be addressed just like you would with any other patient. But I would severely discourage these people from doing that. And in general, weight loss and eating properly is probably going to have a much more beneficial effect on them and helping them live longer than having them take testosterone replacement. Sorry, I hope that was an adequate answer there.
That was very helpful. Thanks. So that was the last question. that we had. And Dr. Green, thanks so much for taking time out of your busy schedule. I know at the beginning of baseball season, as the MLB medical director, it's probably crazy, especially with COVID still going on and COVID protocols and trying to sort through all of that. So thanks again for taking the time to speak with us on performance enhancing drugs. It was an excellent talk. So thank you again.
No worries. I appreciate it, and hope the Braves have a quiet season from a COVID standpoint and do well. But a lot of people have asked me about that. When can you relax for the baseball season? And it's like after the very last out of the World Series, and then we can relax for about an hour and then start planning for next season.
Right. Exactly. Well, thank you again, Dr. Green. We appreciate it.
My pleasure. It's my pleasure. Thanks a lot for setting this up.
All right. Take care. Thank you.